Hey, I'm Michael Ingui. Thank you all for joining us in hour two. For those of you who don't know me, I'm Michael Ingui with Ingui Architecture, also founder of the Passive House Accelerator and co-founder of Source. So I'm super excited to be the one emceeing this round with NYSERDA. NYSERDA has been just a huge force in New York, but also just the projects we're all doing in New York are affecting everybody. So when you really think about what NYSERDA has done for us and is doing for us, it's huge. So I'm introducing Patrick O'Shei. He's the director of market development at NYSERDA, and he's going to be speaking about the remarkable building policy and the progress in New York. So with that, take it away.
I work with the Clean and Resilient Buildings team. And we are currently planning round 5 of the Buildings of Excellence and also getting prepared for the awards ceremony for round 4, which will take place in about a month. And you're about to hear about some of the projects that have been awarded Buildings of Excellence awards by NYSERDA. In round 2 of Buildings of Excellence, all of the projects were fully electric, including domestic hot water. In round 3 of the Buildings of Excellence, 80% of the projects were passive house in terms of their envelope performance, so passive house certified buildings. And also in round 3, we introduced a concept called early design awards for projects that were not at a point in their development that they could step up for a full demonstration, but where we wanted to impact very early in the pre-schematic design process, the concepts of clean energy, all electric, and high-performing building envelopes. In addition to this, I just want to point out that we've used the lessons learned from Buildings of Excellence to be able to propose an all-electric building code in the state of New York, which would take effect for smaller buildings, residential buildings, in 2025, and then larger buildings in 2028. And we're working steadily towards a passive house level performance to be incorporated into the 2028 code. So the work with the passive house networks, the accelerator, the Buildings of Excellence competition have created a lot of learning, and also, very interesting, a lot of cost compression along the way as people have learned to both design and build these buildings more efficiently. A couple of things I would just talk about going forward, in addition to the normal things you think about when you think about a clean, green building. We have been scoring buildings on resiliency, and we'll continue to focus on building more resiliency into our buildings, mostly focused on storms and flooding. We'll also have been scoring our buildings for embodied carbon content, and we'll be looking to enhance lower embodied carbon designs. We're also, as we go into this round, going to focus on the use of low GHG refrigerants and natural refrigerants and their use in buildings. And then finally, another aspect that makes these buildings more valuable is their ability to be grid interactive and participate in actively shedding peak load, both during the summer and winter. We want these buildings to not just be high-performing buildings from an energy efficiency point of view, but to be great places to live, to be beautiful, healthy, and profitable for the investors that invest in these buildings. And I think we're accomplishing all of that with Buildings of Excellence. So thank you, and I hope you enjoy the presentation from the teams.
Thanks, Patrick. That was wonderful, and just shows us just how much we really enjoy working with NYSERDA and how important it is to be in New York, and how much it's really affecting not just New York, but what we're learning everywhere. So I'm now going to introduce Sara Bayer. She's the Associate Principal and Director of Sustainability at Magnuson Architecture and Planning, and she's going to be presenting Carmel Villages Apartments, Casita Park Building, and BOE project. Enjoy.
It's great to be with you. If you were given the opportunity to design a new apartment building in the middle of a dense city, and it was required to be carbon neutral and maybe even regenerative, how would you approach the challenge? Would you believe these goals were even possible? What would be the costs and benefits for your project, for the occupants of the building, for the city at large, and all of the other systems that this project is a part of? Here at MAP, we are continuously searching for answers to these questions. Over more than 3 decades, we have designed 100 multifamily affordable housing developments. We believe architecture now has the tools at hand to get us close to carbon neutral and even reach for regeneration. In the next few minutes, we'll focus on how we approach the path to regenerative architecture through the lens of one project example. This Carmen Villegas Apartments project is a new affordable housing building located in Harlem for seniors from the community. In the future, the owners will conduct an energy renovation on the existing building on the adjacent lot to the north. So the new building design will be mindful of ways to plan for that as well. The approach outlined here by the Passive House Accelerator and supported by many others is an excellent formula for addressing the climate crisis and allowing us to reach for regeneration. We are focused on the climate crisis, and rightly so, but it's important to remember that we're ultimately protecting biodiversity and healthy ecosystems that provide clean air, water, and nutritious food. The focus on climate is important, though, for sure, because if we have an unreliable and out of whack climate, this makes all of the other planetary boundary issues exponentially harder to solve. So here are the other categories of actions we would add to the climate action formula to address those other boundaries. Every industry is expanding their view of what their impacts are, taking more responsibility. We are witnessing in real time this occurring in the construction industry, which is working to establish ways to measure the impacts of these actions and develop the tools to document and analyze them synergistically. You can see by this more detailed summary that there are many actions we can take towards carbon neutrality and reach for regenerative architecture. Many of these are overlapping categories, and they all reinforce each other. Some of them are even code minimum in New York City. Most here are being deployed by this project or being studied closely through the NYSERDA Buildings of Excellence Early Design Phase funding, with the entire project team of the owner, designers, engineers, and GC working together to figure out how to achieve these goals. To start, we begin with passive house design because it's the healthiest and most reliable way to achieve extremely low energy use. The project is committed to FIA certification. Before the project was able to commit to passive house, we needed to decide on a ventilation system to keep the project moving. So using a portion of the BOE early phase funding, we focused on calculating the construction cost and energy savings differentials between exhaust only and energy recovery ventilation. The paybacks shown here were acceptable to the team, and we locked in the ventilation strategy first. Soon after, we were able to determine the upfront additional costs of passive house design and certification. With a baseline of affordable housing that's already 15% better than code, as it's required to be to receive any public funding, the additional increase was only 1.5% of total construction costs. This number, though, doesn't even yet calculate the savings from the smaller heating and cooling system, which we will calculate soon. And the yearly operational savings are about $70,000. The building is also all electric and will be provided with heating, cooling, and hot water by ground source heat pumps. The bore field is intended to be sized to reserve excess capacity for the adjacent renovation. A south-facing portion of the rain screen facade cladding will be building integrated photovoltaics, and there will be solar on the roof as well. Given that we have significant on-site energy resources and a low energy building, we are in the process of studying exactly how close we can get to net zero operational carbon. There are several standards out there now, and more are being developed that help guide these calculations. They typically involve conversion to time of use, which takes into account the carbon intensity of the grid. And they calculate refrigerant leakage and other operational uses. We need to be mindful of the upfront embodied carbon we are spending in order to create this near net zero building and make sure we are hitting the sweet spot where we optimize both with the tools we have at the moment. To that end, the industry needs to increase our capacity to measure embodied carbon, so we are modeling using the TallyCat tool, which is connected to the EC3 tool. The team is examining closely how we can lower the embodied carbon of each material. For example, we are using a combination of the search capabilities of the EC3 and collaborating with our GC's concrete suppliers to get the lowest mix possible. And we have a good start on this project by using prefabricated facade panels by Dextal. We are always looking to use carbon sequestering or biogenic materials, and these are some of our favorites. These types of materials have very low toxicity and can be truly carbon sequestering, especially if grown with regenerative agricultural practices that rebuild the soil. It is important to support human thriving with community building, design, biophilia, and healthy materials. We are also studying here how to achieve a redless-free building. The design honors the neighborhood's artistic culture with a large mural on the east facade and in the ground floor breezeway. This building is not currently in a flood zone, but it will be within its anticipated lifetime, according to the city's projected mapping. So the project will follow the requirements for flood zone resiliency, has a raised entry lobby, and the mechanical rooms are on the second floor. There will also be an area of refuge for the community. With strategic support, such as from NYSERDA Buildings of Excellence program, we can leverage this exciting moment the industry is in and move the market forward towards regenerative architecture.
Thanks, Sara. That was wonderful. And again, very cool stuff. Everything that's in the building, everything we're learning from this, it's yet another great BOE project. I'm in here introducing Grayson Jordan, principal at Paul Castrucci Architects, who will be presenting the Bethany Terrace project, another Buildings of Excellence project.
Hello, my name is Grayson Jordan. I'm the principal architect of Paul A. Castrucci Architects. We're a full-service architecture and sustainability consulting firm located in the Lower East Side of New York City. We specialize in affordable housing and also in passive house buildings. I'm here to talk today about how to deliver passive house affordable housing using the modular project delivery method. Let's start with the why. Why do we care about affordable housing? It's critically needed. New York is a city of 8.5 million people with less than 400,000 affordable housing units. So we need to preserve existing affordable housing and we need to build new affordable housing. At the same time, we know that buildings in New York City, they account for nearly 2/3 of all of the carbon emissions in the city. So on the one hand, we have to build and preserve. But on the other hand, we need to do that in a way that's actually not increasing carbon emissions, both embodied and operational, but actually driving it down. So deeply energy efficient, low embodied carbon, new construction and preservation. Lastly, we are always looking to make places not just new affordable housing, not just energy efficient, but wonderful places to live, places people want to be, places of connection filled with light that are comfortable. And so we have a lot that we're trying to accomplish, often with limited budgets. So we need to explore new ways of building to get more value out of each project. Brings us to Bethany Senior, a 60-unit affordable housing for seniors building that we're in the construction phase of in Brooklyn, New York. We're doing this with the developer Riseborough Community Partnership, one of the leaders of affordable housing and passive house in New York, that brought us on the project. And very early in the project, we sort of mutually said, you know, modular is something that seems to make sense for this typology. Let's jump in with 2 feet and figure out how this works. Just to note, when we're talking about modular, we're talking about 3-dimensional boxes that are built off-site, shipped to the site and stacked up almost like little Legos on site. This is opposed to something else that our firm and many other firms are doing, which is prefabricated wall panels. Also heavily encouraged exploring this avenue, but this prefabricated wall panels is more putting panels on superstructures are built on site. Today, we're talking about 3-dimensional modular. When we think about modular, the first thing is we would want to know is how is this going to affect our design process? And it has, you know, we have to think about things a little bit differently. First of all, we have to think about transportation and staging. We're seeing here delivered box, a modular box. So first thing you need to know is, well, how are we going to get this box from the factory, in this case in Pennsylvania, to New York City? We're going to map out all the routes. We're going to look at bridges, tunnels, any obstructions, and that's going to help shape what each mod looks like. Then at the building planning stage, we're looking for hyper-rational layouts. We're looking for repeatable, very efficient layouts. This can lead to some, if you don't do it right, some sort of formal stagnation. So we have to take these very rational units and lay them out in creative ways. But with modular, it's very important to stay hyper-rational in your layout. We're also going to look at our MEPs quite differently. We're going to completely build all of our plumbing and mechanicals in the units, and then put all the risers on the corridor so they can be easily connected in the field. This is quite different from traditional construction. And finally, we know that design isn't just a series of technical decisions. We care a lot about conceptual and aesthetic response. And here we're really leaning into the modular nature of this and imagining the building as a block of modular where we take one block at a time from the south side of the building and create these dynamic terraces for indoor-outdoor connections, places for residents of the building to enjoy outside, but also be connected to the amenities on the inside. Here's a rendering of that same condition, creating a diversity of places for connection, but also for private relaxation. Moving now to the construction side, how is modular different in construction? And the answer is it's quite different. First of all, we're building this offsite in a factory and an assembly line. Here we're seeing this is the first step, which is building the platforms for the superstructure. This will then be moved down the assembly line, where it will become a 3-dimensional box. So imagine a 6-sided, we'll build 6 platforms, floor, roof, 4 sides. We start to fill these in with stud construction. Then we layer in all the rest that goes in the building. Again, sort of on an assembly line approach. We're going to put all of our insulation, all of our electric, all of our plumbing inside and build it actually in these units, and then follow up with finishes. One thing to note, quality control. Quality control is important on any project, especially with new partners. I think modular gives us greater ability to quality control. We can do this all inside. Here we're looking at a very important detail for Passive House, which is the window detail. And we did this a few times. You can see we've done a pull-up test on the bottom left, and we had this detail redone until we got the adhesion that we wanted. Finally, one thing to note, in this modular construction, these units are nearly done in the factory. So we're looking at finished apartments, finished floors, finished ceilings, kitchen cabinets, plumbing, almost everything except for the appliances, which are shipped loose so they don't rattle around during shipping. And this is done in the factory and then shipped to site and stacked up. So we're going to stack these up. We start with the foundation. The foundation is done while we're building the mods in the factory. And we'll get these stacked up from nothing, just the foundation, up to a 4-story, 60-unit building in 2 weeks. And so that's going to be 60 units of fully completed apartments stacked up in 2 weeks. There's a little bit of work. There's a bit of work to do after this is said. As you can see, there's quite a bit of exterior work. So all of the exterior air barrier and insulation and finish systems happens after the stacking. And then, as we noted before, there's quite a bit of sort of connecting mod to mod of your sprinkler, your plumbing, your electric systems in the corridors, and the corridor then has to be finished. And then, as I noted before, there's some ship loose items such as the appliances that we're seeing here. And if we have, in this case, very large light fixtures that we don't want swinging around, those will be installed in the field as well. To summarize, this is our first modular project. I think in many ways it's a good success. We learned a lot of lessons. I think this is a strong way of building that we should be doing more of, and we should be sharing our lessons learned, because I think that this is a way, especially in affordable housing with reduced budgets, to get really exceptional buildings, passive house level performance at the same cost or even reduced cost.
Thanks, Grayson. That was wonderful. So again, so many different project types, so many different solutions. Love seeing the prefab. I'm here to introduce Jeremy Zuidema, founding principal at Camera Architects, who will present 439 West 36th Street as well as 49-501 9th Avenue. Enjoy. Thanks.
I'm presenting our 3 buildings that won the Building of Excellence Award from NYSERDA in recognition of their ultra-low energy design as the first passive house projects for the Hudson Yards area of Manhattan. The site, Hudson Yards North, is located immediately above the new skyscrapers that define Hudson Yards. Midtown lies to the east with major bus and rail transport hubs nearby. Unlike the surrounding context, the blocks of Hudson Yards North are marred by the Lincoln Tunnel infrastructure carved out of them, resulting in a heavily trafficked, relatively lightly developed neighborhood. These 3 buildings are located across 2 sites. 2 buildings are corner sites that face 9th Avenue and back onto the Lincoln Tunnel entry. The third is an infill site at West 36th Street, near where the tunnel exit meets the city grid. We pushed for passive house early on in this project, which the client was quick to embrace, as this would not only be appropriate from a macro environmental standpoint, but would also impart many micro environmental benefits for these particular sites. A healthy, quiet, and comfortable environment for the end user is a valuable sales pitch when your neighborhood is one of the most heavily trafficked areas of Manhattan. Both of these sites fall under a contextual zoning district, which limits the permitted height and dictates specific setback requirements. Working within this framework, the 36th Street site was configured to orientate itself away from the heavily trafficked tunnel exit and provide views, particularly for the upper units, towards the river and the new Hudson Yards development. In plan, this meant pushing the cords to the easterly side of the site with unit arrangements organized efficiently around them. This also allowed for a maximum commercial footprint at the ground floor. At the setback floors, a permitted dormer extends the building to the street line at the southeast and reduces at each floor in accordance with the permitted zoning envelope, resulting in the tiered massing. This massing informed the cladding design that is expressive of this gradual stepping with projecting vertical fins that curve to become horizontal at the respective terminating floors. In addition to the aesthetic expression, these fins also provide passive shading to the windows and reinforce the idea, even at the lower floors, of orienting the views toward the west. Looking at the facade in greater detail, the cladding is a composition of ultra-high density precast panels, or UHPC in short, with metal infill and metal spandrels. The panels are organized in a double height stagger pattern, which reinforces the tiered massing and produces a tectonic logic for the cladding. A slight tonal differentiation in the cladding delineated the setback portion from that of the street. The 2 buildings at 9th Avenue have a very different contextual relationship, as both buildings occupy a corner site with the sunken tunnel entry at the rear, making every elevation visible from the street. On 9th Avenue, we wanted to be respectful of the existing building, which in order to use up all the floor area available is being cantilevered over. To that end, we stepped the street wall up from the middle with the greater bulk located at the corners. At the back of the building, we opened up 2 courtyards to provide light and air to all the residential units, which also opened up the opportunity to introduce daylight into the cellar spaces. As the contextual zoning required setbacks, we worked within these parameters to inform a massing that is broken up through subtle changes in the street wall, as is further expressed in the cladding articulation. In plan, each building has a double height lobby and a recessed entry off the side street. This gives a residential entry that is both generous and formal, but also expresses its semi-private nature. Pushing the residential entry to the side street allows the 9th Avenue frontage to be fully dedicated to commercial uses, adding more life to this stretch of 9th Avenue. As we move up through the residential floors, we can see how the courtyards serve to give light, air, and views to the rear-facing units, but also open up the elevator lobbies to receive natural daylight as well. The buildings take advantage of the unique setting to provide generous curved windows at the corner, thereby opening up expansive views for many of the units. The curved corners represent a softening of the building form, which is picked up in a cladding expression of subtly fluted, repeating vertical elements bisected by stronger horizontal lines. Sometimes these are simple floor delineators where the slope helps to express the vertical fluting, elsewhere where they become a stronger datum, either forming a horizontal articulation on the facade or projecting deeper to become a balcony. Like our 36th Street building, these 2 buildings are also clad in UHPC panels. Subtle variations of the cladding tone differentiates the various forms as expressed in the earlier massing slide. In addition to providing spectacular views, the curved windows also open up the opportunity to have more generous balconies within the limited projection permitted over the property line in New York City. Both buildings benefit from a shading strategy integrated into the cladding design, whereas 9th Avenue utilized balconies and horizontal articulation to provide shading to a significant percentage of the windows. 36th Street achieves this through both the vertical fins discussed earlier and a horizontal sunshade that forms part of the window system. In order to maintain the continuity of insulation, both buildings utilize concrete thermal breaks in the balcony construction and in the upstands at roofs. With the upstands, this was particularly beneficial in maintaining the continuity of insulation while also providing a simple fixing zone for the parapet cladding and railing without having to worry about additional roof penetrations. The facade in all three buildings will be built using a panelized construction system where the cladding, windows, and insulation all arrive on site as a single prefabricated unit. UHPC has exceptional strength and density, meaning a typical 10-foot by 10-foot panel only requires 4 points of fixing, minimizing the amount of thermal bridging. The properties of UHPC itself allows it to act as water and air barrier for the building. The strength of UHPC allows it to support the window and all required design loads without the need for a structural backup wall. In detailing, we had to carefully consider the joints between panels, a keyed panel design, vertical joint system, and sufficient seal to ensure there is a positive drainage route and multiple lines of protection. The placement of the windows within the panel was carefully considered to balance the requirement for the cladding to support the windows while providing sufficient thermal continuity with the insulation. Both buildings utilize air source heat pumps for heating and cooling, allowing every unit to have control of their own conditioned space. In 36th Street, hot water is provided through individual heat pumps, water heaters in each unit. In the 9th Avenue buildings, hot water is through communal heat pumps, water heaters with storage tanks, and the mechanical bulkheads. All the buildings utilize energy recovery in the ventilation system. There were a number of challenges we had to overcome to achieve a passive house design in these projects, but we believe the main takeaway is that if passive house can be achieved on complex sites like these, there's no reason it cannot be replicated across the city. We equally believe that achieving passive house does not need to mean sacrificing well-considered design in the pursuit of performance. We look forward to seeing these three buildings come to fruition over the next couple of years and the transformation in concert with other developments happening in the neighborhood that they will collectively have on the area, both urbanistically and in inspiring a new crop of high-performance buildings. Thank you.
Thanks, Jeremy. That was fantastic. I'm here to introduce Carmel Pratt, who's the co-host of Passive House Accelerator Live's Next Gen series, and hers Raider and CPHC at Bright Power. Carmel's going to talk about the RISE project, another great one. Thanks.
Hi, my name is Carmel, and I'm honored to be highlighting the RISE during today's NYSERDA Sprint. The RISE is a NYSERDA Buildings of Excellence Award winner and a project that is paving the way for sustainable, healthy, and resilient mixed-use development in NYC. The project site is located in an area with a disproportionate share of environmental justice issues and was part of a state RFP called Vital Brooklyn, which is New York State's comprehensive community development strategy to address social, economic, and health disparities in central Brooklyn. The initiative focuses on 8 integrated areas of investment. These areas include affordable housing, open space and recreation, healthy food, economic development and job creation, education and youth development, community-based healthcare, violence prevention, and resiliency. Thousands of projects have been funded to date through this initiative. The developer of the RISE is a woman-owned Xenolith Partners. They were interested in providing housing for formerly incarcerated women, recognizing the need at this particular location. They've teamed up with other like-minded partners to create a project that is focused on lifting up and supporting these women, hence the name, The RISE. To this end, their goals were to deliver quality housing and create a safe, healthy, and supportive environment to help rebuild successful lives. To make this a high-impact project that maximizes the co-benefits of integrated strategies. To partner with local organizations to provide targeted comprehensive programming, and to deliver all of this in a highly sustainable and beautiful building that serves as a focal point as a source of pride in the neighborhood. The project team consists of Magnuson Architecture and Planning, where the credit goes to for all these presentation images. MAP is an experienced passive house architecture firm focused on retrofit and new construction affordable mixed-use housing. The general contractor for the project is Bruno Frustacci Contracting. The MEP designer is Dagger Engineering. The landscape designer is Terrain NYC. And Bright Power, where I work, is providing the Passive House and Enterprise Green Communities certification and verification. The project is currently design certified for PHI and EGC and is over 50% constructed. To deliver the certification goals, the team designed this 7-story all-electric passive house multifamily building, which contains a large community facility space on the lower levels and a garden on the roof. It will provide services such as employment, training, fitness, arts, therapeutic gardening, education, and other programming together with the partners on the project. Of the 72 units, 65% of the dwelling units are affordable and supportive for formerly incarcerated individuals and families. The remaining 35% are affordable for households earning 30 to 60% AMI, area median income. The architect sought to make the goals of the project visceral to the design. The massing is generously set back at the main facade to create a landscape space at the street level, as well as stepping terraces that rise up towards the corner and are fully accessible to the residents. Their main roof functions as an urban farm and is open to both the residents and the community. Project Eats is the local partner that's providing programming and management of the rooftop gardens. Other on-site supportive services are provided through the Women's Prison Association, the Osborne Association, and other local organizations, including Community Capacity Development and the Brownsville Think Tank Matters. These organizations are providing education, job readiness, employment training, violence reduction, health and wellness, fitness, and arts programming. Back on the building level, the all-electric and passive house design is the cornerstone for the health and wellness strategy for this project. Our industry now understands even more fully how code minimum construction, shown on the right here, is not providing a truly healthy living environment, especially with regards to fresh air and thermal comfort. We cannot indicate we are providing a healthy building if we do not reduce toxins and have balanced filtered ventilation. Beyond the principles that make for a better and healthy environment for building occupants, the sustainability features included on the project are also incorporated to respond to the climate crisis that our planet is currently in. This helps to reduce and or mitigate carbon emissions related to the construction and operation of this building. The specifications of this project's robust passive house thermal enclosure far exceed code. The building massing resulted in a less than ideal form factor or surface to volume ratio, and the larger windows resulted in higher window to wall ratio. These were design priorities that were ultimately combated with triple pane windows, R50 roof insulation, additional thermal bridge mitigation strategies, and passive house level airtightness. To provide heating and cooling, we are using a common VRF split heat pump system with condensers on the roof. We must be careful with these systems as they require the running of refrigerant lines between the indoor and outdoor unit. Current approved refrigerants for this use in New York City have a high global warming potential if released through leaks. But if we are intentional, we can minimize the risk by optimizing the refrigerant routes. Usually in a small building, this means vertical runs. By avoiding heat recovery on the system and instead providing the same flexibility for thermal comfort by zoning the condensers by facade, we can dramatically reduce this risk and also cut significant costs. You can see how much piping we're able to eliminate from the design on the right-hand side this way through vertical distribution. If a project is focused on health, passive house is the best way to achieve good indoor environmental quality, which is dependent on your ventilation strategy and requires flushing out of contaminants and replenishing of oxygen. Contaminant control is achieved via eliminating interior combustion, meaning no fossil fuels exist within the building, having a smoke-free building policy, including walk-off mats at entrances, and achieving apartment compartmentalization, meaning reducing air leakage between units. Healthy materials are achieved by eliminating or calling for low VOC products, floor score and green guard finishes, calling for health product declaration or HPD in your specifications, providing solid cleanable surfaces, and a simplified material palette. The Rise has a predicted source energy use intensity of 21.15 kBtu per square foot per year, which is over 5 times as efficient compared to average New York City multifamily building stock, and 4 times as efficient compared to the 2020 Energy Code, which was in place at the time of design. The estimated operational carbon emissions are well below the threshold set by the New York City Local Law 97 through at least the 2030 compliance year limits. The site EUI is further reduced through the use of on-site solar PV generation system to offset base building loads and sell back electricity to the already constricted grid infrastructure. Thank you so much for listening, and it was a pleasure to highlight this project, The Rise.
Thank you so much, Carmel. That was great. And thanks to all the speakers. Just a word about what we just saw and how we're seeing it. And I'd like to say, just as a designer, these are all great looking projects. They happen to perform well. They happen to be NYSERDA BOE projects, which is all cool. But they're great looking. People would want to move into this. It's wonderful. And it's great to be a part of it. It's great to be part of New York. So thank you so much. Speaking of, I'd like to also announce that the award ceremony for Buildings of Excellence Round 4 is going to take place on April 2nd, both online and in person. Super excited to hear about the winners.